do a quick intro on the structure of the talk. We'll talk a little bit about the state of the industry, so what's been going on and some of the examples of interesting things going on lately. We'll talk a little bit about how cybersecurity attacks are changing, and we'll talk about some of the emerging threats. One is insider attacks. You've seen the session. Where is it? Okay. You've seen the session, the keynote session from Stacy talking about insiders and spies and things like that. Those things are actually on the rise. It's more often than not that attacks originate from within the company than from the outside. So you're no longer safe if you think, hey, I've got my firewall and it's protecting me from the bad people outside. Well, those bad people could already be on the inside, and they could not even know it. It could be somebody who's just harmless, who just clicked on a link or an attachment and had some malware installed on their computer. So now the bad guy starts his attack from within your network instead of doing it from the outside. We'll talk a little bit about credential reuse and password spraying. We'll have some demos, if the demo gods are with us this year as well. And then I'll talk a bit about how to deal with this, discussing about the assume breach approach and how to build your breach incident response policy. There might not be time for questions, but we'll take them on the corridors, at the community corner, wherever. You'll find me around for the next couple of days. So last month was fun, right? For one, we had 4 newly announced vulnerabilities in Intel CPUs. Pretty much most, if not all, relevant Intel CPUs that have been released since 2011 have these issues. These issues have been known since last year, if you remember Spectre and Meltdown. But they have not been made public. Intel asked the people who found them to, like, please hold on for another year while we figure out if there's anything we can do. What they figured out in one of these cases is, yes, you can get rid of this if you disable hyperthreading, right? Which is, it took them a year to realize that. So that's one thing. And we've got some others. These are all from last month. So not last year, these are all last month. Some pre-installed Dell software on Dell computers allows hackers to do remote hacking. It's the software that's meant to keep those computers up to date. That's vulnerable. Some hackers breached Stack Overflow's QA site last month. TeamViewer found out that they had been hacked by Chinese hackers back in 2016. That was last month. Google Titan security keys were found to have a Bluetooth flaw, but it's okay if you have one of these. Google's offering free replacements, right? Because it's okay. So lightning strikes, and apparently that interferes with the equipment. Who knew? Google discovered that they were actually storing passwords in clear text for 14 years for all their enterprise customers. Okay. Microsoft also released a critical patch for what they call a wormable flaw. You can just search for Bluekeep out there. And something that was quite out of the ordinary, they actually released a patch for Windows XP in 2003 as well, because of how bad this thing is, even though they theoretically are not releasing patches for those anymore. Some Israeli hackers used a 0-day to hack into WhatsApp. So if you don't know about this, it's a spyware that would install on your phone by just having WhatsApp on and having the bad guy, the hacker, call you. So start a video call that you didn't even have to answer. So just starting that call was enough for the malware to also install. It's a cool way to do software. And also something about Cisco devices. Many of them let attackers implant a backdoor. And you just need to search for Thrangry Cat. The logo is 3 angry cats. That's the thing. Now, just to name a few, these are just some of the highlights from last month. If we go a little further back, there's a bunch of others that you might have heard or not. Now, looking at this slide, who here has heard about, knows what it's about? It's names of companies that have been hacked. It's names of known vulnerabilities, and it's just names of known tools, like malware tools. Anyone here able to recognize 50% of these? All right, that's a good show of hands. 75%? Okay, so nearly half the room is at or about 50% of these. The fact that you don't know about these doesn't mean they don't affect you. It doesn't mean they don't exist. You just don't know about them. And whether you deal with IT security or not, just being aware of some of the stuff that goes on out there is really important if you want to protect yourself against those types of attacks. If you don't know them, you don't know what to protect yourself against. Now, when it comes to security, there are some fundamental concepts that you find pretty much everywhere. One is precaution. Hey, let's try to avoid getting hacked, right? It's a noble purpose. It's something that many people, many companies try to do. Then there's maintenance. Now, this is the part where a lot of companies start to fail, because you have to do this constantly. You have to stay up to date. You have to keep your systems up to date. You have to just be on top of things. Because unlike software development, where if a new version of platform X or solution Y comes out on the market, you don't need to know about it immediately. You don't have to learn about it today. You can just spend the next few months just learning about it, because you're probably working on 2 versions behind on the current project. So you're good. In security, if some issue is discovered today and you don't know about it today, you might have to update your resume tomorrow. Right? It's that fast of a change. So in keeping up to date with everything, this is a constant thing that you need to do. And then the third thing, and the thing that my whole talk today is about, it's all about how do you react when the bad stuff happens, when you get hacked. And this is something that companies either don't think about at all, or they do, and their only thought is, well, let's just hope we don't get there. Right? Not planning for anything, not discussing, so what do we actually do? How do we deal with something like this, and what is it that we can do differently to discover stuff faster, to address these things faster? And like I mentioned, insider attacks are on the rise. In 2018, it was, you can look at multiple sources, it's 30-ish%, originated from insiders. And very few companies can say they can consistently detect insider attacks. So it's a little over 10%. That means that if something happens, you can't really know about it. You can't really tell, because you can't tell abnormal behavior, like a bad guy doing something legitimately, using a legitimate user on your network, from that user. So you can't tell whether it's the person that has the username and password doing that stuff, or if it's somebody else using their credentials doing that stuff. And not being able to tell means you're not going to be able to tell when someone just hijacks those credentials and uses them for something bad. Not only can't they consistently do that, they don't actually monitor for that at all, a lot of them. And they also say it's very hard to determine what the damage could be, because it could be considered. So it's clearly an issue that's arising. And for the people in the room who were here last year, you might remember this, the underwear study. This was a study made by the guys over at Kaspersky. And they likened passwords to underwear. They said you should basically treat your passwords like underwear. That is, you should change them often, you shouldn't leave them lying around, and you shouldn't share them. And you might find this funny, but the results of the survey were a little more interesting. So they had a few questions. One of these questions, would you say right now that you have more pairs of underpants or panties or shorts, whatever, than you do passwords? Like, and you can see the shy people in the room raising their hands. This is what the situation around Europe looks like. And even in the best case scenario, to your right, which is the Netherlands, 71% of people said that they do have more panties or underpants or shorts than they do passwords. And no, using password and then password 01 and password 02 and password 03 doesn't count as different passwords, right? So that's one thing. If you are meant to change your password because of a company policy that says you should do that, and you just think of your current password and add one at the end, because you've got a counter at the end, that's not a new password. For any tools and any sort of attacks that will use your base password, they will do that. It's just adding 100 numbers to the end from 00 to 99, and that's it. It just takes an extra second if they know your core password. Second thing, speaking about your underwear and your passwords, how often do you change them? Please do not raise your hands here. Let's just see what people answered confidentially. So it does seem Germany has a good way to approach both changing their underpants and changing their passwords. Not sure about British people, though, here. Third question, have you ever shared your underwear or password with a friend or member of your family? Again, please do not raise your hands. A good thing is for UK, right? I mean, considering the previous question. At least they're not sharing their underwear. But it just goes to show that people do not really care about their passwords as they should. And let's see why that's an issue. For one, a lot of password collections abound. If you just, and that's a link on Wikipedia, just search for collections 1 to 5. These are basically collections of passwords from over 2,000, and now it's, I think, over 4,000 or 5,000 if you search for the latest version of the collections, previous data breaches. So these are actual pairs of usernames and passwords that were discovered in other data breaches. So if you use the same password in 2 places, and one of them has been hacked, essentially the second one could easily be hacked as well for you because you're using the same password and you're probably using the same personal email everywhere. So you don't have to have the strongest software and the best security if you use the same password everywhere and one of those things gets hacked. And that's how they'll reuse. So collection 1 had about 700 something million emails and 21 million unique passwords. These are passwords that people use in the wild. Now you see, just look at the difference between the unique emails and the unique passwords and think how many people actually use the same password if you just divide that by like 700 something million by 21. That means that there's a lot of passwords that are used by the same people, or the same passwords used by different people, sorry. The next round of collections are estimated to be 3 times the size of the first collection after removing duplicates. Now, there's a bunch of places on the internet where you can check whether, one, your email has already been compromised in an attack, and also whether the password that you're using has been found in a known data breach. And no, you cannot search for the pairs. You just search for one or the other for obvious reasons, right? But if you do search for this collection, and I'll probably show you one such collection towards the end of the session, and if you want, during the break, you can come and search for your email there. I'll step away from my laptop and let you do that. You might be surprised to maybe find something there. Now, these types of leaks are the ones that are used in credential stuffing attacks or credential reuse. What's that? It's just about using those sets of known credentials, those sets of emails and passwords, email and password pairs, in trying to see, hey, I wonder if this guy uses the same username and password on Facebook as he does on LinkedIn and some other place, or Twitter, or whatever. It's easier. It goes much faster than any brute force attack or even a hybrid attack. And it's bound to hit more correct pairs of usernames and passwords. And this is what's actually been happening lately in a lot of places. This is how a lot of emails get hacked. It's not because, I know, Office 365 is vulnerable. It's because you're using the same password you're using for your Office email on your Facebook account or whatever obscure forum you've been to once that's been hacked since. There's another attack called password spraying, and it doesn't look like the picture. It's not like spraying passwords. It's about trying to circumvent lockout policies. Usually, when you want to try out a number of passwords, any system that you're trying to do this against has a lockout policy, saying if this person or this account tries the password wrong 3 times or 5 times, let's just lock the account out or just throw a CAPTCHA or something. So it's harder to do brute force attacks. However, if you just go with 1 or 2 or 3 common passwords and just try all the users with that password, just looking at some statistics, by the way, 1, 2, 3, 4, 5, 6 is used by about 2% of people. Now, you work in IT, you probably know better, so I doubt or I hope that none of you here uses 1, 2, 3, 4, 5, 6 anywhere. But it's about 2%, so that's 1 in 50 users. So just trying 1, 2, 3, 4, 5, 6 means you'll hack 1 in 50 users if you just know their username or their email on any website. Now, if you look at trying to avoid that lockout, there's a bunch of tools out there, and they're readily available. They're open source. I've linked them here. You'll get the slides. You'll get the recordings. You can take a photo. But they are used for this precise reason, and they can automate this. You can tell them, hey, I want to hack OWA or RDP or Cisco VPN, anything that uses authentication. And I'm going to tell the tool, try all these users and try these passwords, like the top 10 passwords, and make an attempt every, say, 35 minutes to avoid the 30-minute lockout or 5-minute lockout or whatever. So it's not going to be thousands of attempts in a very short time. It's just going to be 10 passwords over, what, maybe 10 hours, 20 hours, however long you set the threshold to. But in that time, you're bound to hack into a lot more accounts than you think. So with that, we go to the demo side, and I will tell you that these are some demos that may not work from the get-go. But it's just trying to show you how easy it is to do some of these things if you know what you're doing. First, it's going to be about how to get someone's passwords and how easy it is. And second, hopefully that demo works, it's about how to bypass MFA as well, multi-factor authentication. Now, before we do this, show of hands, who here knows what the Arp protocol is and how it works? All right, so that's maybe 15 hands. So let's do a short intro there, because you'll understand how this demo works or why it doesn't if it doesn't. Whenever you're on the internet, whenever you're connected to any network, and I do mean any network out there, including, who's connected to the free Wi-Fi at the hotel right now? There you go. You'll see why that's probably not a good idea by the end of this demo. So say you're on a wireless network at a hotel, at an airport, restaurant, whatever. Whenever your computer or your phone tries to connect to, say, facebook.com, it needs to know how to get there. It needs to know how to get from where I am now to wherever facebook.com is. And as you may know, the internet is nothing else than a network of networks. It's a bunch of interconnected networks communicating with each other, and you need to just find a route through the internet from your IP to the destination IP, to what facebook.com points to. So first you do a DNS request, and you ask, hey, so what's facebook.com's IP? And you get a reply like it's 1.2.3.4, and you know the IP. Now your IP is 5678. How do you get from 5678 to 1234 over the internet is how the ARP protocol works. The first thing your computer, phone does is it will try and follow the protocol. Now, as many protocols invented in the age of like university professors building the whole concept of the internet, it's just like TCP/IP and DNS and a bunch of others. They were built with the assumption that everyone using them will just respect the rules, they'll be a good guy, they'll just follow the rules, they won't do anything funky. And that's the whole assumption. And that's why we have DNSSEC and IPv6, because that thing worked out fine, right? It's the same with ARP. How ARP works is, if you need to know that, the protocol says, just ask, right? And what my phone and my computer will do is it will broadcast a message to the network that I'm connected to, which is usually the subnet, right? To the entire subnet, so it's a broadcast. And it will ask, hey, does anyone know where 1234 is? Now the protocol says, if you know, be a nice person and tell him. If you don't, just shut up. That's problem number one, and we'll see why. So the assumption is I'm connected to the internet Wi-Fi, which has one of these antennas somewhere around here. And it's that thing, or the gateway, or the router, so it's the access, it's something that allows me to connect, and it's usually the gateway connecting network 1 to network 2 that routes the things in between. And that's the device that will respond. And it will respond to me because it heard me yelling, hey, does anyone know? And they'll say, well, you know what? I don't know, but I might know somebody who does. Do you want me to ask on your behalf? And then you say, yes, sure, I trust you. You just answered, so I implicitly trust you. You're a nice person. You're a nice device. So what this device will do is it will turn over to the other network that they're connected to, and they'll ask, they'll do a broadcast, and they'll ask, hey, does anyone know where 1234 is? I'm asking for a friend. I'm asking for 5678. So if anyone knows, please tell them. Now the second thing, in this other network, I might find 2 or more devices, because as I get further along in the internet, I might find multiple routes to the same endpoint. So at any given time, I might get 2 or more devices in the network replying back with the same thing. I don't know, but I might know somebody who does. Do you want me to ask on your behalf? What the protocol says is, now if you have 2 or more devices answering, just talk to the one that answered fastest. That's the most trustworthy. That's the most reliable. They're the fastest. That's the only criteria. That's problem number 2. So whenever you get 2 or more replies, you'll just talk to the one that answered fastest. It's sort of like a heuristic, greedy approach. At every step, you try and find like the closest node to you. It doesn't mean that end-to-end, the route will be the shortest. It does mean that at every step, you'll just talk to the device that answered the fastest to you at that time. Now, in all this process, all these devices that are nice enough to ask on your behalf will also be nice enough to pass over any requests and any packets over the network from one to another. And they'll do that for you with the assumption that they're nice enough not to look inside. That's problem number 3. Because you assume they're just trustworthy, because you're passing over all the traffic through them. So whenever you do a trace route, whenever you do, like if I need to go on the host. So if you just try and figure out, hey, where's Google as compared to where I am, or where's 1.1.1.1, sorry about that, I'll see this trace route that tells me that from my IP, it goes through a bunch of hops through the internet, and it ends up somewhere that's 1.1.1.1, right? So it's, I'm trusting all these hops in between implicitly. Now, the way Arp Poisoning works, and we're getting to the first demo, the way Arp Poisoning works is I, as the bad guy, want to do something that does not really respect the protocol's requirements. So what I need to do, and it's easier if I just do it this way, I just need to ideally be on the same network as my victim, which could be the hotel's Wi-Fi. Right? I mentioned why this might sound like a little worse idea by the end. So I'm on the hotel Wi-Fi. As opposed to wired networks, which just take an extra step for me to force them to send all the traffic to me as well, instead of just the destination. On wireless, since I'm connected to the wireless network, I can listen to all the other conversations, because it's just a bunch of devices yelling at each other over radio. It's radio technology. So I can hear everyone on the network. And another problem with the Wi-Fi protocol here is, by default, all network cards are designed to just look at any packets on the network that are destined to them and ignore, drop everything else. That's a simple switch that you do on any network card, put it in what's called promiscuous mode, and allow it to listen to everything else. Right? It's like you're a nice guy, you're just ignoring everyone you can hear talking because you're not interested. But then you start to listen to them. You're looking somewhere else, but you listen to them. It's the same on Wi-Fi. So on a Wi-Fi network, you basically see all the traffic. So you will see anyone asking where Facebook.com is, where 1234 is, sorry. So what you do at that point, even though the protocol says if you don't know it, just shut up, you will respond as the bad guy. And you will tell the other device, you will tell the device, hey, I don't know, but I might know somebody who does. Do you want me to ask on your behalf? If my response gets to the victim, to the target, faster than the one from the gateway, what does the protocol say? Well, just talk to the fastest responder, right? So if I'm just a tiny fraction of a millisecond faster, I'm your trustworthy person. You'll pass everything through me, and all I have to do is just ask the gateway, because I know the gateway will eventually get me that information. But now the difference is all that traffic goes through me. All of it. Where's the problem here? Well, there's a bunch of protocols out there that use what's called plaintext encryption. Right? You've got FTP, you've got HTTP. By default, they're unencrypted. POP3, IMAP, SMTP, Telnet, they're all unencrypted. There's others that are encrypted by default, like SSH or RDP, but a lot of them are not. You need to do some extra funky stuff to have SSL over HTTP, right, HTTPS, or have, like, use SSL or TLS with POP3, IMAP, and SMTP for mail servers. But by default, they're not encrypted. So let's see how such an attack looks. For one, the bad guy is the red thingy over here. They're .11 on the network, and the good guy, the target, the poor victim is .12. So I'm the bad guy. I just start a tool that I know I need to start. I don't need to know a lot about these things. It's just stuff that you can find out in a quick search and a 2-minute YouTube video. It will just show you what I'm showing. And this is a lot of the times enough for most hackers to do their job. It's a 5-minute research on YouTube on how to hack stuff, right? So what I need to do, first off, is I need to look, hey, who's on the same network with me? And I see .1, which is my host, so my laptop. I see .10, which is another machine we'll use in a minute. And I see .12, who's the victim. I don't see .11 because I don't want to hack myself. It's intentionally omitted here, so I'm .11. So now I know who's on the same network with me. So all I need to do is to go to the Arp Poisoning tab and just set it so that whenever .12, I could, right now, if I were connected to the hotel network, I could literally see everyone connected, and I could select everyone here, and I could say, whenever any one of these devices asks about anything, just tell them you know. Just do that. And try and force them to go through you. Right now, I'm just going to target this .12. So I've done this, and I've said it just do poisoning. So right now, this device is listening to all the traffic on the network. And in case anyone asks about where something is, they'll also respond. They'll also try and help out. So say I want to connect to an FTP server. I enter a username. I enter the wrong password intentionally. So it's login failed. If I had entered the correct password, I would have been connected to the FTP server. I saw nothing. FTP is unencrypted. However, if I come here and I go to the passwords tab under FTP, let me just minimize this. Let me actually minimize a bunch of things because I want to zoom in. There we go. So it tells me that this client wanted to connect to this FTP server using this username and this password. So anything that's unencrypted just passes through me anyway. So I can just see it, right? Now you'll say, well, of course, but I use encrypted stuff. I use HTTPS everywhere. It's all encrypted. Well, this thing has got a list of stuff that it can detect and potentially decrypt, or just at least give you the keys that you can try and crack in some other ways. You might recognize some of these other protocols out there, right? Let's see how things look when you want to connect over HTTPS. And once again, yes, this might not work from the first try, especially on the web, because usually browsers try and open multiple connections to the same web server. And I need a lot of them, or the most important ones, to be forced to go through me. So it might not be that all of them are done that way. Well, let's ensure that it's HTTPS accounts Google.com. So I want to connect to my Gmail account. This did not work from the first try, but there were some requests here that did work, and what this software also does is it tries to create some self-signed certificates and trick me into getting that self-signed certificate instead of the real one. So this did not work. What I just need to do is just get this and maybe try again. And this might work with some accounts on the network. It might work with, you see, some connection did go over through the bad guy here, because I can already see some certificate errors, but it wasn't the main connection. But if we just go at this long enough, we'll get to this. Has anyone ever seen this before? Or in some form or another, you can see it in Firefox and Chrome and things like that. So what do your IT guys tell you when you want to connect to your internal Jira server and you get this? you know, our management is too cheap. They don't want to buy like commercial certificates, and we're too lazy to use Let's Encrypt because you have to refresh that every 3 months or whatever. So we just use self-signed stuff because they're trusted automatically. So whenever you see this, just click continue, right? The guys over at Berkeley University actually did a study on this, and they concluded that anywhere between 30 and 70% of people actually click continue here, regardless of what they've been told, because they want to read their email, they want to go on Facebook, they want to do stuff. And this thing right here stands between them and the stuff. They will not check what's wrong with the certificate, they will just click continue. And maybe, hey, this is not loading. Maybe if I click display blocked content, okay, this is working. I'm gonna ignore the fact that the bar at the top is fully red. I'm just gonna ignore that. I'm just gonna go enter my email and enter my wrong password, right? It is the wrong password because I'm connecting to Google here. I'm not connecting to something, it's Google. But it's Google going through the hacker's computer. So if I go into the passwords tab, it tells me that, hey, so there's this guy on this IP that tried to connect to this URL using this password. So it's all about just clicking ignore, accept on that warning. If you do that, you're gone. Your data is at the mercy of whoever's doing this to you. Unfortunately, some mobile phones and some apps don't handle this really well. They either don't check whether they just check whether the connection is encrypted. They don't check whether the certificate is trusted or not. Or if they do, and they realize, hey, this is weird, they'll tell you something along the lines, so you know, since the last time you connected, the certificate on the server has changed. Do you want to continue? And there's no like more information, show me the certificate, I want to look at it. It's like, do you want to continue? And you'll just assume you're not the IT guy in the company, you're just doing random stuff. You're not in charge of changing certificates on the server. So you will just assume, hey, so I don't know what my IT guys did. I'll just, if they changed it, they change it. I'll just hit continue. So not enough apps out there give you this information and let you inspect the certificate, especially mobile apps. So it's easier to do this while targeting mobile phones than it is in browsers. Now, even in browsers, like I mentioned, if roughly around 50% of people click through this, you're bound to have a bad day anyway. Now you'll say, of course, but I'm an IT person, so I can look at this certificate error and I can see that yes, it's just a self-signed thing. It's not trusted. There's no chain here for the certificate. I can see who generated it. I can see it's being generated to be valid from. It's not from today. It's smart enough to do that, but it's recent enough to allow me to think, hey, maybe I haven't connected in a while, so this is probably a new thing, so whatever. But I'll see all these things, and by this time, there's a whole bunch of certificates generated here and requests over HTTPS that went through. Now, how about trying to trick someone into thinking that maybe Facebook.com is on my machine? And I'll show you a different kind of attack. So I'll have to first stop this because it's going to use the same techniques. And actually, I'll turn this off completely. And I'll do something else. I'll connect to this machine, which is a nice distro based on Debian. It's called Kali Linux. Anyone here that never heard of it until today? So you all know of it. Oh, there's a few people. Essentially, this is a version of Linux that has a few hundreds of tools meant for, let's say, testing out security, right? Yes, it's hacking, but it could be used for pen tests and legal stuff. And it's meant as such. Because if you don't have access to the same tools that a bad guy does, it's hard for you to protect against those. So it's easier for you to use those tools, but to use them for good. It's like I always say, the information that you need as a hacker and the tools that are just that, tools. It's just like with a hammer. You can build a house or you can hit someone on the head with it. It's what you do with the tool. It's not the tool itself that's the problem. All right, so what I'll do is something called DNS spoofing. If this thing will start. There we go. Okay. I'll actually edit this directly. DNS. And let me just make sure that I've got the right IP. So, so it's 192.168.200.10. So what I'm going to try to do is convince the victim on the same network that I am to be convinced that Facebook.com is on my IP, which is .200.10, right? The way I'm going to do that, because now you know how ARP poisoning works, is I will do a couple of things. One, I need to create a copy of Facebook, right? And I'll do that using the social engineering toolkit. It's just like the name says, it's a toolkit used for social engineering attacks, and it's got a bunch of them. I'll use a social engineering attack, which is a website attack vector. I'm doing credential harvesting. You see there's already a number of, and I'm going to do site cloning on this IP for facebook.com. Yep. All right. So right now, if I'm on the network, and if I go to 200.10, I get the Facebook page. And it's already detected that I'm connecting from Romania, so the page is in Romanian. It's all good. But I won't be able to convince you by just going around during the coffee break and telling you, hey, you know what, if you want a faster Facebook, just connect to 192.168.200.10 instead. It's going to be it's the same Facebook, but it's just faster, right? I'm not going to be able to do that. What I'm going to be able to do, however, is to trick your computer into thinking that Facebook.com is on this IP. And I'm going to do that using ARP poisoning, convincing all your connections to go through me. And once they do, guess what? DNS is unencrypted. So if you ask where Facebook.com is, I can just answer you whatever I want. I'll just replace the legitimate answer with whatever I want and tell you that thing. So in order for that to happen, I need to do one more thing. I need to start another tool that does that, right? So it's all about knowing the right tools. I start sniffing on the network. I go to the plugins page and I enable the DNS spoof plugin, which uses the file that I edited earlier, the config file with the IP. And I'll just do a couple more things with reply and repoison. This is not mandatory, but it usually speeds up the process. So now that I've configured DNS spoofing, I need to know, hey, so who's on the same network that I am? So it scans the network. It's the same thing that I've done in the other tool. Now that I know the list of hosts, I can maybe add .12, that's the target, and .1 to target 1. So anything going between 1 and 12, just try and get through me, and I'll just start doing ARP poisoning on the network. So right now, this poor guy, the target, he connected to FTP, he read his email, and now he wants to connect to Facebook. So if I do a ping facebook.com, what do I get? That IP. So if I go into like any browser out there and I go to facebook.com, I get facebook.com, right? The only thing that would stand out, and this is why HTTPS everywhere type of initiatives and HSTS and stuff like that help, is I will notice that this page is unencrypted, right? It's over HTTP. But that's the only thing. There's no warning in the browser or anything. So if I enter my email, and my password, there's a couple of things that happened. One, and I should show you here, I need to scroll up a bit. There we go. Let me catch the password as well. So if you look here, there's an email and there's a password, right? So I got the password. However, another thing happened. I only redirected facebook.com, if you recall. The other stuff was commented out. So right now, I've been redirected to www.facebook.com, which is the legit website, which if I had been logged in, would have already, and Facebook does that for you. They do a great job keeping you logged in. Right? I would be logged in on my Facebook account. So I would just see my Facebook account. I would be none the wiser that, hey, I just gave my Facebook password to somebody else. And this is essentially a combination of the attack from before and some other stuff around DNS poisoning. So that's the second thing. And then the third thing that I want to show you, and I'll just pause these, is something having to do with multi-factor authentication. And for that, you'll see, well, of course, if I had multi-factor authentication here, I would have needed to see something on my phone or whatever, and that would have at least told me or made me think that, hey, this is weird. This shouldn't happen, right? Because I'm not getting a thing on my phone. Maybe I should check my password or just reset the password. So if you're expecting something there. Now, let's do this with LinkedIn. So if I go to LinkedIn.com and log in, you can set multi-factor authentication. So I've done that for an account. And the whole point of this thing is to try and convince a person to click on a link that you've sent them and make them think like that's the real website. And I will be doing this with another tool called Evil Nginx. It's an evil version of Nginx, right? As the name implies. It's a modified version of Nginx that acts as a transparent proxy between you, the target, and the real website. It gets the real website, it shows it to you, but it does it under a different domain. So you need a domain that you would use. I actually bought this domain. It's called authorization.co.ro. It's like €1 per year or something. So I bought this, so I own this. What I needed to do is to set the name servers and point them to the place where this tool is installed. This will act as a DNS server. It will go out there and fetch some Let's Encrypt certificates for me automatically. And it will do this magically for LinkedIn, Outlook, Amazon, Facebook, Reddit, Twitter, Citrix, Instagram, and they keep adding stuff as people add this stuff to the tool. So what I need to do is to basically send someone a link such as this one. Right? This is not LinkedIn. If you're not careful, it looks like LinkedIn, but it's not LinkedIn. So I get an email that's a phishing email. It's meant to look like a LinkedIn email, and I click this link, and I go to this page, and it's the LinkedIn login page. And it is the LinkedIn login page, only it's copied through my funky web server out there. So I'm going to log in. It's John the victim. Let me see if I remember the password correctly. So I'm trying to log in. It's telling me that, hey, you should receive, and hopefully the phone lines work here, because the signal is quite wonky sometimes in the hotel. So I'm still waiting for the code. I can try and resend it maybe. It's usually problematic. This is where phone connectivity suffers. So this might not be a spectacular demo in the end if I don't get the SMS. My phone does end in .70, so this is my phone number here. However, thanks to, I'm not going to name the company, the mobile company. So I'm still waiting for it, apparently. This is the only part of the demo that relies on too much external stuff to work. And you might be thinking, yeah, but let's see, reconnected. I've actually reconnected to the network. So let me see if that that helps. It does not. Well then, thanks to the demo gods, apparently this is not going to work. I would, so what would happen is I would actually log in. I would be on the network. I would be on the website using my actual username and password. The only thing is I would be on this website, linkedin.com.authorization.co.ro. However, I would be able to do pretty much anything because it's the same website. It's just transferred to me through a transparent proxy. The tool itself does get under, so I already got the username and password. That's not that spectacular because I've already shown you some other ways to do that. But if I go to sessions, I can see that I did get the session, I did not get the tokens. If I were to look at this session, it doesn't give me that, oh, yay, the SMS arrived. Maybe. I think the first one. So hopefully this gets me in. Oh, wow. Okay. So I'm John Victim, right? So I'm in my LinkedIn account. This account only has one contact, which is my LinkedIn account. So I do get the recommendation to grow my network, but I'm in. Okay, so this is this has changed because now I have this part right here. I have the tokens. Now, what do I do with this? And I will use this. I will copy and paste. So I've got essentially what LinkedIn saves in the browser to just keep you logged in, because they won't ask you to log in again and again for a little while, but enough time for me to do this. Say I close this, so I'm not connected. That was an incognito window anyway, but it's a new incognito session. So if I go to LinkedIn, the actual LinkedIn, I'm not signed in or anything. But there's this tool right here that allows me to, and it should work by importing because this is JSON format. Their last update made it a bit harder because it doesn't work. It says it does, but it doesn't. So I have to add the cookies manually. So what I will do is I need to set the name to the name. It's HTTP only true. The expiration date, I will set it to maybe 1 hour from now or something. But it's in 2020. It's okay. I shouldn't even set that. It's LinkedIn. I will use this domain. It's .linkedin.com. And then I will just keep the value as the value. So this is manual JSON import. So I've imported that. Okay, so now if I refresh the page with no two-factor authentication whatsoever, I'm John Victim in this browser. Yes, yes, I do. It's a sponsored message. Someone found and sent like a message to CEOs out there. Yeah, so it's a nice thing. Now, this took a little longer than I wanted, so I will briefly go through what to do about this. But you will get the slides anyway. So the problem with all of this is it's that easy to get into stuff. So you need to think about not protecting yourself against, but how do you actually react? How do you handle these situations? And this involves a change in mindset. And that's called assume breach. Its emphasis is on breach detection. It's on figuring out if anyone's on your network doing bad stuff. And for that, you could look at creating an incident response plan. And this is the part that I rush through in 1 minute, but you will get the slides. You need to create that incident response plan where you first try and discover bad stuff going on and confirm that yes, it's bad stuff, it's not a false positive. So you need to look at some things like how did you find out, look at logs, try to describe who would do this, if it's an actual attacker, is it somebody on the inside that's just disgruntled, or is it somebody on the outside that's just hacked some of my people. Check your applications and your infrastructure for signs of breach, evaluate the extent of the damage, and then inform your people that, hey, we've just been hacked. Sharing information outside usually means you have to also look at compliance. You might be able to hide this for a little while at this time where you've just confirmed you've been hacked until the next phase where you've contained it. At the point of containment, you have to let everyone else involved know. It's not about compliance, it's not about hiding stuff, it's about maybe trying to take the critical measures before you do that. And protecting evidence and just not shutting down machines, just maybe disconnecting them from the network would work better for the forensic side of things. You need to force multi-factor wherever you can, change passwords for relevant services and whatnot. And then you go into the eradication phase where you try and get rid of the stuff. Industry averages show that it takes anywhere between 6 to 9 months for an attack to be detected and about 3 months for the eradication phase to occur, for you to actually get rid of the bad hacker stuff in your network. So that's not a good sign. And this is what we're trying to avoid here. Then you try and figure out how do you best get back after the bad stuff happened. And then you draw some lessons out of it, and then you figure out how you can protect yourself better for the future, what you can do better the next time this thing shows up. If you can avoid it, try to avoid it, but you might not be able to do it entirely. It might just be a different kind of attack that you'll hit, and you need to be ready for that. And just to wrap up, looking at passwords, try not to reuse passwords because a lot of password attacks work by just reusing stuff that's already been hacked out there. Try and stay up to date with current attacks and stuff that's been going on, because that's going to help you be better prepared and take better measures against these things. Educate your users. 90% of people, or over 90% of people, can't distinguish a phishing email from a legitimate one. And it would have been that easy to send out that LinkedIn link if 90% of users would just click it. And I only need one to actually click it if I want to hack into your stuff. Start using that assume breach approach. Start thinking about, hey, what do I do when I get hacked? Because it's not hard to get hacked. It's just a matter of time more than anything. And do create that cybersecurity response plan. Now, with that, I am done. If you want to check out those funky password databases and check to see, I've got a database that's about 1.4 billion emails and password combinations that you can easily check out. It's on this machine right here, and if I resume, it's resuming. It failed to resume, so I need to restart it. But I have it here. It's like I mentioned, it's 1.4 billion usernames and passwords. You just need to search for your email and figure out whether your email has been in a data breach, and it will also tell you. So if I go to passwords, it's query, query billg@microsoft.com. You'd be amazed how many people use this email for their own account, because they assume Bill Gates will never create an account on this website. And these are some of the actual passwords found in actual data breaches. I surely hope this is none of this is Bill Gates, but I surely hope none of you use passwords such as these.